everyone. It's great to see such a large audience today. Today, I'll be doing a SQL crash course for beginners. So this presentation is going to be for you if you are a complete beginner, meaning you don't have any prior experience in SQL, you might not even know how to code, then this is a presentation for you. This presentation is not for you if you're looking for a deep dive into SQL coding. I'm going to be going into some SQL code for about a third of the presentation, but the remainder will be on concepts and demos. So a bit about me. I'm currently a data science and analytics instructor. I teach at universities, for companies. I also have videos on YouTube and code on GitHub at A Dash of Data. And over the past 15 years, I've held roles as a data scientist, analyst, consultant, and engineer. And one thing that was common in all of my roles is that I use SQL. And so I took everything I learned from working in all these roles, from startups to big corporations, and I put them all in this book, SQL Pocket Guide. So this is a reference book. It contains 10 chapters on all things related to SQL. My goal was to make a really dense book in terms of information, but very easy to understand. And we're going to be focusing on the first chapter of that book today, which is the SQL crash course. So I've taken that chapter and kind of blown it up into this hour-long presentation for you today. And like Nathan mentioned, we're doing this free ebook giveaway, which I'm really excited about. So if you're interested, please fill out the form in the link that is going to be shared in the chat. Okay, so let's get to it. This is your SQL crash course. So we're going to start with some basic terms and concepts, then move into some example data, and then get into SQL coding, and then finally end with a short software demo. And the reason I have that demo at the end is a lot of times when I'm teaching, people will be like, oh, everything looks so pretty in a presentation, but how does that actually work? And I just want to spend some time at the end doing that. Okay, but to get started with the basics, we're going to start really basic. So we're going to start by defining the term data. So in this presentation, I'm going to say data is information that's stored by a computer. And this information could look like this, like numbers, some basic text. And it could also be more complex, like audio, images, videos. These are all different forms of data. So now that we know that, we can move on to the term a database. And this is a term I'm going to be using a lot in this presentation. So a database is a place to store data in an organized way. So if you think of one piece of data as this Lego, you've probably heard it in the news all the time, but people are like, data's everywhere, we're collecting a ton of data. Well, if you were to collect a ton of data, it might look something like this. But the problem is, if your computer wants to work with that data, or you want to analyze that data, you can't really access it if it's just in a huge pile like this. So instead, you have to organize it in some way, like a database. So this is an image from Instagram. I'm really into home organization, but you can see here that the Legos are organized inside this piece of furniture by color. And that's really what you can think of a database as too. It's a way for a computer to organize or give some structure to all these little pieces of data so that you can easily access it later on. And one thing I want to note is that there are many ways to organize data, just like there are many ways to organize Legos. So you can organize it like this, or like this, where it's kind of like similar colors, or even like this, where they're just in big buckets. There's many ways to organize data. They all work depending on your situation. And you can kind of think of it as different companies have ways of storing their data, and they all do so in different ways, depending on the company and their needs. So quick checkpoint to go through everything we've talked about. Data is info that's stored by a computer, and a database is a place to store it in some sort of organized way. There are many ways to do so, but two of the most popular ways are called SQL, using a SQL database, or you could use a NoSQL database. So I'm going to dive into that SQL term just a bit more. Okay, so SQL stands for Structured Query Language. Some people call it SQL. I like to call it SQL, but you'll hear both pronunciations. And the part I really want to focus on is that it's a language. So Imagine that you have this app on your phone that stores all your friends and family's birthdays. If you were to use the English language to talk to it, you would say, hey app, when is my husband's birthday? And then the app would give back a birth date. But you can also use this other language called SQL to ask the app, and it could look something like this. So this is some SQL code, and it's essentially asking the app the same thing, and you would get the same thing in return. So again, SQL is a language that you use to work with the database. Okay, so now let's combine these terms, SQL database. So SQL is a language that you use to work with data. And then a database we talked about is a way to store data in an organized way. So if you put those two together, it's specifically the way a SQL database is organized. It's specifically when data is organized into something called a table. So if you've worked with spreadsheets before, you've seen tables, but tables have columns and they have rows. And within a SQL database where everything is organized into tables, you will have multiple tables. So maybe one that shows the birth year, one that shows favorite colors and fruits. And all this together, again, is called a SQL database. One other term you might hear from time to time is that this table is referred to as a relation, and this SQL database is referred to as a relational database. So those are typically the terms you'll see in textbooks, but more commonly you'll see them referred to as tables. And so again, the SQL database is where we can store our data, and we can use the language SQL to then talk to that database and get the data that we're looking for. Okay, so at this point, I've given you a lot of terms and theory, so I'm gonna take a step back and show you a real world example to solidify these concepts. You probably recognize this icon here. This is the Messages app on an iPhone. This is where you can text back with all your friends and family. And so, not sure if you knew this, but with this Messages app, every time you receive or send a message, all that data actually gets logged in a SQL database. So on my MacBook, if I go to all these hidden folders, I end up finding a database that's called chat.db. And within that chat.db, there are a dozen tables, and two of them I see right here. So there's a handle table that has a bunch of phone numbers. There's this message table that has all the text messages along with who sent them, whether I sent them or I received them, and so on. And so with this database, what's pretty cool is that instead of, like, let's say you wanted to find a text message from like 2 years ago, instead of like scrolling up until you see that text message, you can actually write some SQL code to find that text message in this database. So let's say you want to see all messages that have been liked. You could write the SQL code onto this database. Like I could do this right now on my computer, and then I would get that message in return. So this is where you see the power of SQL. This data is organized in this really structured database so that you can pull the information that you need. Okay, so to summarize all the terms we talked about, SQL stands for Structured Query Language. A SQL database is made up of these tables that you put data inside of. And then it's sometimes called a relational database. So one other thing that you'll hear is that SQL databases require predefined schemas. And so a schema, you can think of it as kind of a plan or a blueprint for your tables or for your database. So imagine you have this big database where you plan to hold all your text message data. You can't just throw information in there. You actually have to first plan out what tables are going to be in there, what columns are going to be in there. So first, your schema that you would come up with would include a table that looks like this, and then you would insert data into it like this. So you can think of this kind of like the home organization example from earlier. So if you have all these Legos, before you start storing your Legos, you first buy this piece of furniture and you label, this is where the reds and orange and yellows will go, and then you can put in your Legos. So that's how SQL databases work. So on the flip side, there are some things called NoSQL databases. And I'm not going to go deep into this because we're focused on SQL today, but I want to mention this because I always get the question, like, what's the difference between SQL and NoSQL? Are they related? They are related in that they both deal with databases, but NoSQL stands for not only SQL. And the way that NoSQL databases work is they have dynamic schemas. So what that means is you don't have to have this, like with SQL, you have this rigid structure with all these tables and you pre-plan everything. With NoSQL, you kind of can just throw data into your database. And so this is an example of a NoSQL database called MongoDB. And you see here, there's kind of this data that's thrown in here and this other data that's thrown in a second. What these are called documents. But what you can see here is the data is not in tables, but it's in here in some organized way. So if you think of it in terms of the Lego example, imagine we have a big room and we want to store Legos inside, and I buy the classic Lego set, I would just store it in that box and just put it back in the room. And I buy the Harry Potter set, put it in the room, and so on. So you see here, this is just a different way of storing data. And SQL or NoSQL, they both work in storing data. It really depends on what your needs are for your company. So I want to note that there are many types of NoSQL databases. MongoDB is just one of them. And sometimes you'll see these called non-relational databases. Okay, so I want to do one more summary of everything that we've covered so far. These are all the terms that I've introduced since the beginning of the presentation. And I'm going to put all these terms in just a few sentences on the next slide so that you can have a quick overview of what happened. So SQL is a language, and you use it to work with data in a relational database. So this is what the language looks like, and this is what a relational database looks like. You can see here there are a lot of tables, and everything has a lot of structure, and the data is planned out. On the flip side, you have a less rigid way of storing data, which is using a NoSQL or non-relational database. Okay, so those are the basics. Moving on, now that we know the basics, let's look at some data. So the data that we're going to be working with today is some school data. So imagine you work at a school and you need to keep track of all your students and their grades somehow. So the current state is that all of your students and their grades are in multiple spreadsheets. And this is pretty common. You put data into either Google Sheets or Excel, and it's fine for now, but there are a few issues. So one issue is that there's no single location for the data. So every department has their own spreadsheet, and you want to be able to share that information somehow. You want people to be able to go to one place with all the tables or all the spreadsheets. And then also, Google Sheets is really easy to override something on accident. So you want the data to be locked down so that people don't override grades as easily. And then also, there's more students, so you need some better way to manage the data. So a great solution for this is to come up with a student grades database. And this is where you would have multiple tables to store your data. And in this student grades database, there happens to be two tables. One that has all the student information, including their names and their birthday, and then another one that has a bunch of grade information. So for every student, it lists the classes they've taken, the grade they got, and then the date that grade was entered. So one thing I want you to note is this first column here. So in both tables in the first column, there are IDs. And so one thing in SQL is every row of data should be unique, and then every row of data should be given some type of unique ID. And this isn't the same as in some other places like Excel or Google Sheets. You don't have to have those be unique, but that is the case in SQL, is that every row needs to be unique with a unique ID. And that field that contains the unique ID is called a primary key. So we're going to come back to this term just in a bit, but just remember the unique ID is also called the primary key. Another thing I want you to note here is that the tables are connected to each other. So in that students table, that first row with Alexis in it is connected to 3 rows in the second table. based on that student ID. So the first row has Alexis and her birthday, and then the second row has all of Alexis's grades. And so the thing to note here is you can match the rows in one table with the rows in another table. And also that you could have one row match multiple rows in another table. And again, this is a concept we're going to loop back to in just a bit. So one other place I want you to look at is that bottom table there with the student ID in purple. So this is the field that links the two tables. So you'll notice there's a student ID, unique ID in that top table. This student ID down here matches that student ID in the top table, and together that field is used to link the tables, and that field is called a foreign key. So what I'm going to do now is summarize everything we've just talked about into one picture. So this visual here actually incorporates everything we've talked about in the last few slides. And this visual is called a data model. So a lot of times, if you join a company and they have a SQL database, there's going to be a data model associated with that database, which tells you how that data is organized. And so let me just go through all the terms in this data model, and then I'll talk about it a bit more. But you'll see here that this database has two tables that you see in the rectangles. And then everything listed below is one of the column names that we saw. You see that the primary keys are highlighted here in purple, and they're labeled PK for primary keys. That means that that column contains the unique ID for the tables for every row. And then in the middle, you see this little fork looking thing. And what that means is that one row in the student table matches many rows in the grades table, which is also known as a one-to-many relationship. And finally, you'll notice the FK right there. That stands for foreign key. And that's how you know how to link up one table with another table, how you know there's columns that match. So again, this visual here is called a data model. And every database will have a data model associated with it so that when you look at it, you can kind of figure out how everything is organized. And once you figure out how everything is organized, then you're able to actually write some SQL code. Okay, so that was our example database section. So now let's start writing some SQL code using that example database. So at this point, we know the basic SQL terms and concepts. We have this database and we're kind of familiar with the fields in there. So you can do a few things at this point. You can read data from the database, or you can edit data in the database. So reading data from the database, this is where most people start and even stay. So if you're a data analyst, a data scientist, you're going to read data from the database and use the data from there. If you want to edit data, that means like creating the tables, inserting rows, deleting data, things like that. Those are usually the jobs of a data engineer or a DBA, a database administrator. And we're not going to go into that territory today because most people start by reading data from a database. That's where we could be covering next. So the first thing I want to say is I'm going to give you some terms that you should be using going forward. So instead of saying reading data from a database, the term you'll hear a lot is querying data from a database. So whenever you want to read data, you can say, I want to query the database. And just a shout out to SQL, remember, that was a structured query language. So that's where that term comes from. And then this is the most basic SQL code you could write. Select all from my table. And you'll notice here, this is called a SQL query. So I just want to know one thing. At the top, query is the verb. At the bottom, query is a noun. So query is used a lot in SQL. So you would say, I'm going to write this SQL query so I can query data from the database. That's how you would use it all in a sentence. And what this query down here means is show me all the data within the table called my table. So next, what we're going to do is break down this SQL query. So the first thing is you'll notice there are some purple words here. These are called keywords. And in any programming language, a keyword is going to be some word that's reserved by the language, or that means that word already has some meaning. So whenever you type it in your code, the computer is going to do something. You'll notice here is, this is the name of the table. What this star means is all columns, and I'm going to go through that a bit more in the next slide in just a minute. And at the end of every SQL query, you write a semicolon. That's how the computer knows, okay, this query is done, and now I can run it and read data from the database. So one question I always get at this point is, does capitalization matter? And the answer is no. SQL is case insensitive, which means if you capitalize or lowercase what's going on here, it's all going to run the same. But typically, the standard is that keyword should be in all caps and everything else should be lowercase. Okay, so now let's get to writing some queries. So this was a students table from our student grades database. And if I write my most basic SQL query on it, this is what I get in return. So all the columns are returned. I can say just return the student name, and then just that column is returned. I can say return these two columns, and then those two columns returned. So at this point, you probably sense this pattern going on. This first keyword here, select, whatever you write after it, those are the columns that are going to be returned. And then this keyword from, whatever you write after it, that's the table that it's going to query from. And in this case, we have one table, but you can also query from multiple tables. So what we've just gone through is a SQL query, and it had a select keyword and a from keyword. But SQL queries actually can contain these 6 different keywords. So I'm going to go through each of them in detail in the coming slides. And one thing I want to note is that instead of calling it a keyword from this point forward, I'm going to call it a select clause. So that whole first line is called a select clause. The whole second line, that's called the from clause, and so on. So within a SQL query, these are the 6 clauses that you typically see, and I'm going to talk about them in the coming slides. So next, let's talk about the where clause. So the idea of the where clause is that if you add it, you can filter your rows. So let's say we have all this data in our database. So far, we've been able to pull specific columns that we want, but next we're going to pull specific rows that we want. So I can add this where clause, and it's going to only give me those top 3 rows of data. If I put in, so this one's a little bit more complex. I've added specific columns I want in the select clause. I've added the filters in the where clause. And so this is really going to narrow down my data. So these are the 3 columns I want. And then these are my filters here and here. And the only data that matches all those constraints is that first row, where the course name is Intro to SQL and the grade is greater than 90. And then I've only selected those 3 columns. So at this point, you're probably seeing SQL queries. The whole idea is that there's data in a database and I want to read it somehow, and I can do it using these keywords. So I'm going to skip a few, and I'm going to go to the last one down here, which is the order by clause. And this is where you can sort your data. So if I by final grade, you'll see in this last column that I can sort all that data. And when I say descending, it means from highest to lowest. I can also add some additional keywords here. So in this case, I want the distinct course names, meaning I see 5 rows of data, but I only want the unique ones. And so there's only 3 unique course names. So distinct course names will give me those unique values. And then I want to order by it, which means it'll sort it alphabetically. If you leave out the descending, it's going to sort it alphabetically. Okay, so we've gone through some of the simpler SQL queries, but you can do some more advanced things as well. So when you're working with data, a lot of times you just want to pull the data that you see, but you can also aggregate that data in some way. And that's when things become more meaningful. So maybe you want to sum some rows or average some rows, things like that. And to do that, you would use the group by clause. So the way the group by clause works is, let's say my goal is to show each student's average grade. What the group by clause, I'm going to go through this line by line, but what the group by clause is going to do is it's going to be able to collapse some of those rows into a single row. So again, I'm going to go through this step by step. The first thing I want to talk about is that top bolded line right there. So that is called a comment. And if you've coded before, you know what a comment is. For those who haven't coded, you can think of a comment as basically, it's like where you write your notes for your code. That line doesn't get run by the code at all, so you can write whatever you want. So in SQL, the dash dash allows you to comment. And then you'll notice that there's this group by down here. So what the group by does is, when I say group by student ID, it's going to look at all the different student ID values. It's going to see all these 101s. It's going to see all these 102s. And then this concept is called grouping. So it's basically grouping all these values within student ID. And then what you can do is you get to choose how you want to summarize that data. So in this case, I'm going to say, all right, I'm going to take all these final grades. I want to average them. And I'm going to take all these final grades and I want to average them. And that average AVG there, that's called a function in SQL. So you can think of a function as a calculation, and average is just one of the many calculations you can use. And then the next part of this code, you see this as average grade. This is, you can see, matches that column name in your output. So this basically allows you to rename a column in the output. And this is called an alias. So with all this, again, what's happening is I take that 101, my goal is to group by student ID. I take that 101 student and then I average their grade. I take that 102 student and then I average their grade. And I was able to do that using the group by clause. So one other thing I want to note here is that you see that group by student ID, the student ID column in the group by clause, and also in the select clause. Just one tip, if you're writing SQL code, whenever you do a group by, whatever you list in your group by clause must also be listed in the select clause. That's just one tip. But at this point, we've gone through the group by clause. And again, what it does is allows us to split the rows into different groups and then to summarize them in some way. And the last clause we're going to go through is the having clause. So the idea of the having clause is, this was our situation from just before. But if I add the having clause, I can basically filter on some type of aggregated value. So in this case, I'm going to filter on that average final grade, and I'm going to only want the ones that are greater than 90. So that second row would disappear, and this would be my output. So the having clause you can think of as always working with a group by clause. If you group the data in some way so that you've summarized some value, you can then filter on that value, and that's the having clause. Okay, so we've gone through a lot of clauses. I'm going to say once again, the goal of a SQL query is to pull data from a database, and you can either pull it as is, filter things, you can sort things, or you can even kind of collapse the rows and summarize them in some way. And in addition to these 6 clauses, there are many more things that you can do with SQL code, including pulling different tables together, maybe like adding an extra IDs to all the rows, more calculations and so on. But every single SQL query you write, anytime you write code to talk to a database or to pull data from a database, it's going to have some combination of these 6 clauses. And so before I move forward, I just want to do one more query with you. I'm going to go through it. I'm going to go through one query that has all 6 clauses so you can see them working together. So you'll see I have all 6 clauses here, and this is what the query would return. So I want students with average grades above 90, and that would be this student here. And you can see this is different from before. I had the ID here, and now I actually have the Alexis name here. So the way this worked was with the select clause. Again, use that to figure out what columns you want in your final output. The from clause, normally, so far we've gone through queried from one table, but here you can query from multiple tables. And what I've done here is I've joined together the students and grade tables based on their matching ID, which is that student ID column. And then in this case, with this filter, I'm saying I don't want to include rows where the final grade is 0. So maybe the teacher hasn't entered in that data yet. So that's final grade is not equal to 0. And then I'm going to group by student name. So again, what the group by does is it takes this student and this student, puts them in their own groups. And then what I'm going to do is, if you look at the select clause, I'm taking every student name and I'm going to be calculating their average final grade. So I'm going to average those, and then that's how I get my output here. Oops. That's how I get my output there. Sorry, I went a little bit fast, but that's how you see I was able to combine Alexis and that 94.7. And then with the halving, what that does is allows us to filter on the aggregate. So this is what the data would have looked like before. But if I filter, then I see that only that first one is above 90. And then I can sort the data with an order by. And in this case, I only have one row, so it's already sorted. Okay, so that was all 6 parts of a SQL query. And if you're going to work as a data analyst or a data scientist and you want to read data from a database, you would write a SQL query to do so, and it would always contain some combination of these clauses. So one thing I want to note here is that SQL clauses must always be listed in this order. So you have to write your select, then your from, and so on. And people always ask why. That's the way the computer interprets the code. It has to be in this order. And there's many ways to remember this order. I had a contest on LinkedIn a few months ago where I asked people to come up with their own mnemonic to remember this. And the winner, Chandni, she came up with this great mnemonic: sword fights will guarantee headless opponents. And that's select, from, where, group by, having, order by. Okay, so we went through a lot of code there, but the main things I want you to take away from this section is, as a beginner, if you want to work with a database, you're going to query the database, which means you're going to pull data from it. And within a query, a SQL query, the clauses must always be written in that order. So at this point, we've learned the basic concepts and terms of SQL. We've gotten familiar with the data set and that data model. You understand the structure of a SQL query. And so from here, the best way to get familiar with SQL code is to practice coding. And the way to do that is within some software. So one question, again, I get all the time is, where can I write SQL code? And the answer to that is so many places. So you can write SQL code within some RDBMS software, which I'm going to define in just a bit. You can write it within a database tool. dbeaver is one of them, but there's many options for this. And you can even write SQL code within other programming languages like Python or R. So today I'll be demoing SQLite, and I'll also be demoing dbeaver. Okay, but let's start with RDBMS software. So what is an RDBMS? It stands for Relational Database Management System. And you actually see this acronym all the time. But an RDMS is essentially software to use to work with a database. So within an RDBMS, you're going to be able to store, you're going to be able to create your plan for where the tables go. You're going to be able to store data. Usually there's going to be extra things like people can set up permissions of who to access what database and things like that. And this is where you would go to write SQL code. And so there are many RDBMSs to choose from. These are 5 really popular ones. And you'll see here that some of these RDBMSs are open source, meaning that they're free to use. And you might wonder, well, which RDBMS should I use? I'm just getting started. So the one that you choose really depends on what other products you're using. So all this software is going to allow you to write SQL code, but you want to choose one that's closely aligned with other tools that you're using so they can possibly connect with each other. And also you can see what people in your industry are using. And that helps because if you go online into forums and you need help, then if other people are using similar tools, they can help you troubleshoot. So for Microsoft SQL Server, if you use other Microsoft products, like you have a Windows machine, use Azure, that's a great one to choose. If you are into web dev, like HTML and CSS, MySQL is a good one. A lot of big companies will have Oracle. And then if you are into data science, like that's my background, Postgres is really popular because it works with a lot of other open source technologies. And then SQLite is a really easy one to get started with, and also open source, free to use. And you'll see it typically used with mobile apps, iOS and Android. So earlier I talked about all of my text messages being in a database. It's in a SQLite database. So all of these here, a lot of times if you're just getting started, you might not be able to, if you're just getting started, you can choose which one to use. But if you're working at a company, they're going to already be using some software, and you would just learn whatever they're using. So I'm going to give you a fun fact that's only kind of fun, but SQL syntax varies ever so slightly from software to software. So SQLite and MySQL, the syntax is going to be slightly different. So to give you an example, let's say you want to return 10 rows of data from a table. Pretty simple, right? Well, the code to do that is actually different in every software. And this took me longer than I want to admit to figure out. So what happened is at one of my earlier jobs, I used SQL Server, Microsoft SQL Server, and I used that top 10 part right there. And then when I went to my next job, the code wouldn't run, and I was too embarrassed to ask people why it wouldn't run, because I was Googling it and it would always say top 10 and I didn't know why it didn't work. So it took me a while to figure out, but now I'm going to pass that information along to you. But whenever you're Googling SQL syntax, make sure you include the RDBMS in your search. So if you say within SQL, I want to return 10 rows of data, type in MySQL after, type in SQL Server after, and that's going to give you the exact code you need to make that happen. Okay, so the main takeaways from this section are for RDBMS, so Relational Database Management System, there's a bunch of software that's out there. So we went through these 5 in the middle here, but you'll see these days with big data, there's cloud-based software, there's Redshift and BigQuery and Snowflake. And you might think, there's so much software, I can't learn them all. And that's exactly right, you can't learn them all. But the good news is that even though every software has slightly different syntax and maybe like a different way of doing things, the core concepts are the same. So everything I've told you about structuring things in tables, the 6 clauses of a SQL query, that will work in all of the software. And then because this is a course for beginners, here are some free resources you can use to learn SQL. I always say the best way to learn SQL is to practice. And it's really nice getting your hands on a database and trying it out on your own. And the easiest RDBMS to set up by far is SQLite. So if you're on a Mac, it comes with SQLite pre-installed. If you're on Windows, you can go to the SQLite website, and then you can quickly download it onto your computer. If you don't want to download something onto your computer, you can also write basic queries within a web browser. So I'm not affiliated with W3 Schools at all, but I just find their website really easy for you if you want to just quickly type in some SQL code and see if you're getting the syntax right. But what I'm going to do now is just a quick SQLite demo so you can see what this looks like. So I'm on a Mac, and within the Mac, there's this terminal application, and it's sometimes called the command prompt, command line. But from this terminal, I'm able to access SQLite. So if I type SQLite 3, and specifically I want to look at the student grades database. You can see now I'm in SQLite. So I'm in an RDBMS at this point. And what I can do is I can say, select all from students. And there's all the students. I can add select all from students where student ID is greater than 102. And I'm able to write some SQL code that way. So you can see SQLite is known for being really lightweight, really easy to set up. And this is how you would write SQL queries within SQLite. Okay, so going back to this, so far what we've done is we've talked about RDBMS software, which is a place you can write SQL code. And next, I'm going to move on to some database tools. So what is a database tool? It's usually some tool that you can use to interact with, where you can use SQL, and it comes with a graphical user interface or a GUI. You can basically think of this as, so in the example I just showed you with SQLite, everything was on this black and white screen, and it wasn't really pretty to work with. Most people don't work directly with an RDBMS that way because it's not pretty to work with. You want something that has nice pictures and things you can click on and things you can drag and drop, and that's called a GUI. And a database tool gives you all these things where you can click and drag and drop things, and there are a lot of them available. So there are database tools that you can get for free, some that you pay for, and they usually all include some type of extra features. In addition to just writing SQL code and holding data in a database, sometimes you'll be able to more easily pull data in from other data sources to work with using that database tool. So again, you can think of a database tool as just like a nice user experience to work with a database. So there are many database tool options out there. For those top 4 RDBMSs, you can see I've listed a common or a popular database tool that's used with those. And then with SQLite, DB browser for SQLite is one of several options. And there's even situations, there's even tools where you can connect with multiple RDBMSs. And the one I'm showing you today that's free is called dbeaver. But again, this is one of many, many options out there. So what I'm going to do next is show you what dbeaver looks like. And this is the way that most people would access a database. So this little icon here is dbeaver. And you can see already, this is a lot prettier than that terminal window, right? So what I can do here is I can say, I want to connect to a database. And you can see over here, these are SQL databases. I also talked about NoSQL. Big databases, there's so many options here. But what I'm going to choose is SQLite because that is how my data is currently stored. And I can say, okay, I want to go to the student grades database. And by the way, this database, I'm going to have it posted on GitHub, and I'll share the link at the very end if you want to play around with it. So there's the student grades database. And over here, you can now see that so you can now see within the student grades database, there's the grades table, and these are the 4 columns associated with it. There's the students table, and these are the columns associated with it. So you can see this is a much nicer way of interacting with the database. And I can also write SQL queries. So if I go to the SQL editor, open up the SQL script, I can now query the database. So select all from students, and you can see everyone's here. And I can do where student ID is greater than 1 to 3. And there you go. And down here, it's really nice. You can even filter, or sorry, sort on here. So this is, I would say, a better way to work with a SQL database. And again, if you're just getting started, I'm using this tool called dbeaver, and I'm connecting it specifically to a SQLite database. Those are really easy to install and start using. Okay, so now that we've gone through the database tool, the last thing I'm going to go through is how to write SQL code within other programming languages. So as you probably know, there are a ton of programming languages out there. So programming languages are used to do tons of things. You can create apps, do analysis, and so on. But if you're working with data, which you probably are, you're going to need to store that data in a database. And if you're storing it in a simple structured way, it's going to be in a SQL database where you're going to need to use SQL. So imagine if you're a developer and you're coding in HTML and CSS, and you want to store the information that people put in forms. Probably want to store that into a SQL database. Or if you're an engineer that uses MATLAB and you want to collect sensor data, that data would be stored. If you're an analyst that uses Python and R and you want to analyze a bunch of customer data, well, that data is probably stored in a SQL database and you're going to need to access it. So a lot of times you'll be able to write SQL code within other programming languages. And the way to do that is that you can start with the software that you're using to write that other code, like Python or R. Let's say I'm coding in R and I want to write SQL code inside of there because I want to do some analysis. So I want to go to a database, pull the data I need, and then do the rest of the analysis in R. What I would need to do is to connect that program to a database. So again, let's say I'm coding in R right now, and the data that I want is in a MySQL database. And maybe there's some other data I want that's in a SQLite database. To connect to those databases, the first thing that you would have to do is install a database driver. And this is not as complex as it sounds. You basically have to download this onto your computer. And what database driver does is it helps R talk to MySQL, or it helps R talk to SQLite. So you would download this. Again, it would be free. You can find it online. And this database driver is called RSQL, and this database driver is called RSQLite. So you would download that database driver. And once you do that, you can start writing SQL within other programming languages. So let's say you're an R user. This is R code right here. But you can see in the teal that I'm using that R SQLite library, and I'm able to connect to a database. And then I can write that last line as a combination of R code and SQL code. Or in Python, same thing. I'm importing SQLite, and then I can then combine the two languages. So this just shows you how versatile SQL is. And also it shows you that SQL is pretty much anywhere. So if you're coding in any other language, it's always good to know a little bit of SQL, just in case you need to work with a database, which you probably will. And that is your SQL crash course. So we went through a ton of information today. I'm going to leave you with this one pager. And this is also going to be on the GitHub link that's going to be on the next slide. But you see here, these are all the things we went through today. I'm not going to go through this page in detail, but you'll see these are some of the key terms we talked about today. And then we talked about this is what a data model looks like. And these are some key terms that you should remember. We talked about queries and how it can be used as a verb or a noun. We talked about these 6 clauses. And if you ever want to talk to a database, these are the 6 clauses you're going to be using. And that slightly fun fact I had, that syntax varies a bit in each software. And then finally, there are so many places you can write SQL code. If you want to get started, go to an online browser or download SQLite. And there's so many other options as well. I would use whatever is at your company. But that's all I had for you today. So you can find me at a dash of data at my website, or if you want to find any of the code that we talked about today, you can find it on GitHub. And that's all I had for you. Thank you so much.
Thank you, Alice, and thank you everyone for joining. I just want to let everyone know I am posting the link to the certificate now, and it will be open until 1:10 p.m. Pacific time. So if you'd like that, fill it out and it'll be sent to you. Alice, we do have a couple of minutes left, so let's go over a couple of questions, and we have about 51 unanswered. So I'm just going to start reading out some of the more popular ones.
Okay.
And I think a lot of them you actually answered as you were presenting. So let's find, here it is, from Mitch Mitchell, and he was on YouTube. One problem with learning software is that you often need to buy expensive programs to practice them. Is there a free SQL database we can download to practice/learn on?
Yes, so I mentioned SQLite is really easy, free software to use. So I would recommend downloading SQLite software, and that's going to give you basically a place to write SQL code. In terms of a free database, so a database would be like the actual data you're going to practice on. I would say you can go to Kaggle. I know in the past, one database I've used a lot, I forget the exact name. It's called Soccer. It's like a soccer database.
Oh, okay.
And at the end, it says .db. That's how you know it's a database file you can use. So I would say Kaggle for the actual data, and then download SQLite to have the software to write code.
Awesome, thank you. And then on top of that, I know some people, and I can't find the question now. It was also a question on YouTube, and a couple of people were posting in the chat. They were looking up MySQL or SQLite, and in the Microsoft Store, there were a couple different options, and they weren't sure which one to choose from. Is there like an option that you prefer, or is it just any of them that say it's free? Go ahead and download it.
Okay, so the only options I can think of is for SQLite, there's just going to be, you would download SQLite. For MySQL, there is, I think I know what you mean by options. So some of them will just be the RDBMS, some of them will include extra tools, and some of them are free versus not. So I think the MySQL one, it's called MySQL Community, but I'm not exactly sure. So I would Google it and then just search for like MySQL, like free software. And then I think Community Edition is the free one.
Okay, great. And then maybe this was kind of answered during the last question, but what is a good place to practice SQL for technical interviews?
So I would say the website I recommended was called W3 Schools. That's going to be a really basic place to practice. But for interviews, I always recommend downloading some database, like the soccer database from Kaggle, and then asking some questions. Like you would list the questions on your own. So things like, which soccer team had the most scores last? I don't know much about soccer, but which soccer team got like the most points last year? Or which teams tend to compete against each other a lot, like that. And then you can write SQL queries against your database to answer those questions. So I would say the best place to practice is downloading a SQLite database, getting a .db file, and writing queries.
Awesome, great. And then from Christian Powell, in the example using student grades, does the relationship break when the value of student_ID is greater than the value of greater ID, since the primary keys are no longer unique?
Can you repeat the last part? So it's when the student ID is greater than? What was that again?
I'll post it in the chat if you want to open that up and read it. But yeah, when the value of student ID is greater than the value of greater ID, since the primary keys are no longer unique.
Okay, so I'm not sure what greater ID is, but I will say that I'm guessing that this question might be related to, there was like one student ID with multiple student IDs in the other table. And the relationship does not break because you can have that one-to-many relationship that is allowed. So I'm sorry, I'm not sure if I answered that question.
No worries. And sorry, I'm scrolling through all of these questions and just trying to find one more that we can cover.
It says greater ID was probably grade ID. Yeah, oh, if greater ID was grade ID, then I think that does answer it. So it is okay for one student to have many grades because that's the one-to-many relationship. And you'll see that all the time within SQL code, within databases. So you have that one line matches many lines. You can even have many lines match many lines. You can get quite complex.
Yeah,
well, one thing is someone asked about the database tool. So the free database tool I like to use is called dbeaver. So we should be able to.
Is that open source?
dbeaver. It's open source, so it's free to use. Yep, the community edition is open source.
Okay, last question, and this has to do with the student example. Why did you start the instructions as s.student and g.student? I'm not sure how.
Great question. Let's see if I can go back. I'm gonna see if I can go back to that slide. So I kind of glossed over that because we were going through so much. But the way that this works is you can see in that from clause, I had the s.student and g.student. I could have technically said students.student ID equals grades.student ID. But you can write this alias, which is basically like a nickname for every table. So you have to write fewer words in your code. So just above that, it says students S, which means from this point forward, S is going to stand for the students table. And then G is going to stand for the grades table. And then I can link them and say, basically S dot whatever equals G dot whatever. And you can see that within the rest of the query as well. Great question.
Awesome. All right. Thank you, Alice. And I'm sorry we couldn't go over everybody's questions. There were a lot of really good ones, and I'm sure we will write a blog post that tries to answer all of the questions we received. There are still about 10 minutes to fill out the form for the certificate, which I'm sure if you want it, you've already done that. I am going to keep the webinar up just so that if somebody wants me to paste the link again, I can do that. But thank you, Alex. Thank you, Alice, and thank you everyone for joining. And I hope everyone has a good rest of their week.
All right. Thank you. Bye, everyone.